We're going to start Unit 1 today. It's covering transformations, congruence, and similarity. The first thing we need to identify is what does it mean to be congruent? To be congruent, it means it is having the same measure. And if you can get the same shape and size of an image through rotations, reflections, and translations, then that will give you a congruent figure. If shapes are not congruent, let's look at examples and non-examples first. So if we look at these two triangles, we can tell that they are congruent because the sides and the angles are both equal to each other. And you're looking at the markings on each side and angle that tells you which ones go with which angle and side. And you can tell with these, the side lengths are the same, the shape of course is the same, and the angle measurements are the same. Non-examples would be that they're not the same size. Notice these figures, the shape is the same, the angle measurements are even the same. If you look at both angle measurements that correspond to each other, all three of them, then look at the side lengths. The side lengths are not the same, but they are related to one another in this image, but they are not congruent. Looking at the definition of similar. Similar means that they are proportionate. It's not just that they're not exactly the same. They have a relationship. They are proportionate to one another. And images that can be obtained that are similar are going to be through dilations. Let's look at some examples and non-examples. These are examples of similar. You can tell that the shape is exactly the same. The angle measurements are even exactly the same, but the side lengths are not the same for this one. Non-examples would be shapes that are not proportionate to one another, or even shapes that are not the same. You have very different shapes that are non-examples. Now we're going to make a Venn diagram. If you are comparing and contrasting congruence and similarity, you're looking at the side lengths, the shape of the figure, and the angle measurements. And this is a Venn diagram describing the similarities and the differences in congruence and similarity. Geometric transformations is going to be any figure that has a change of position and size. And there are four types that we're going to be looking at: translations, reflections, rotations, and dilations. The rotations is the first one we're going to look at. And in a rotation, the figure is going to be turned around a fixed point. That's called the center of rotation. And the object, as it rotates, is going to stay the same shape and the same size. So the word that we use to describe that would be congruent. So if you look up here, you can see a rotation of the smiley face, and you see the center of rotation is the center of the circle. It is going to turn, and you can easily see that the shapes will be congruent. So remember, rotations are what turns when a figure turns. The next one is reflections, and you often see those when you're looking at your reflection in the mirror. The figure is going to flip over a line of reflection, and the shape and the size will both stay the same, but the figures are going to be in opposite directions. And you can see in this image that we have the line of reflection shown as a dotted line, and of course the shapes will be congruent. Remember, the reflections are going to be the ones that flip. A translation is when the object slides, but it's going to slide a specific distance and a specific direction. The object, the original object, and the translated object will stay the same shape and size, and they will continue to face the same direction. So you see the translation, the word is moving to the right and down, to the right and down, but nothing is changing. It's just sliding over. So the shapes will be congruent. And remember, translations are when the image slides. Dilations is the last one we're going to look at, and it's when the object stretches or shrinks in size. So the size is going to change now. In the original object and its dilation, they do change in size, but it's a specific size. There's going to be a scale factor involved. So you're going to have to use that scale factor to determine how big or how small it's going to change. So as you see, it can get smaller or it can get bigger. But the shape will not stay congruent because the size changes, and therefore the shape will be similar.